All right, let's dive in. Today, we're going to talk about the essential Python toolkit for data science. But more than just listing tools, we're going to build a mental model, right? We'll see exactly how you go from a simple question to a real, insightful answer, all by transforming that raw, messy data.
So let's start with a really practical question. I mean, we all kind of feel like a heavier car probably gets worse gas mileage, right? It just makes sense. But how do we actually prove that with data? Well, this is the perfect kind of problem that data science was made to solve. Okay, so to get from that question to a real answer, we've got to have a foundational tool. And in the world of data science, that indispensable tool, the one everyone uses, is Python. You can think of Python as the bedrock of our whole toolkit. And that term you see there, open source, is super important. Yeah, it means it's free, which is awesome, but it's way more than that. It means there's this huge global community of people constantly building new things for it, sharing them, and making Python more powerful every single day. Now, this is what I find really interesting. It's all about the trade-offs. Look, Python isn't always going to be the fastest language out there. Something like C++ or Julia might blow it out of the water in a raw speed test. But that's a choice. Python deliberately prioritizes being easy to read and having this massive ecosystem of tools. And for data science, where you're just exploring and trying to figure things out, that kind of clarity, it's often way more valuable than just raw speed. So how do we actually talk to the computer with Python? Well, at its core, it's really about giving it instructions, line by line. We do this with two main things. First, we use variables. Think of them like labeled boxes where we can store stuff. So we could make a box called car_weight and stick the number 3500 inside. Then we use expressions to do math with those boxes. It's that simple. It's just how we tell the computer exactly what to do one step at a time.
Okay, let's bring in our next tool and see how this all starts to build on itself. To answer our question about cars, we can't just throw a big messy pile of numbers at Python. No way. We need to get all that information organized first. And for that job, we're going to call in a specialist. Just picture it. You get a file with thousands and thousands of rows of data about cars. Yeah, the information's all there. Mileage, weight, horsepower. But it's just a giant jumbled mess, a raw data dump. To do anything useful with this in our code, we have to bring some order to that chaos. And this is where the Pandas library swoops in to save the day. Pandas is a Python package that's built specifically for this, for manipulating data. It lets us take that raw, messy file and load it into a beautiful, clean, table-like structure that's actually easy to work with. So the star of the show here is this thing called a data frame. I'm not kidding. This is the absolute workhorse of pretty much all data analysis in Python. The best way to think about it, it's like a super-powered spreadsheet that lives inside your code. It's got rows, it's got columns, and we can use their labels to grab, filter, and mess with any little piece of data we want. And that is the power of having this structure. See, if we decide we only care about the weight of the cars for now, we can just tell Pandas, hey, give me just that weight column, and boom, there it is. This ability to surgically pick out exactly the data you need, it's absolutely fundamental. Okay, so Pandas is amazing for getting our data organized, but what's giving it all that muscle to do calculations so fast? What's the engine making it all go? Well, to understand that, we gotta pop the hood and see what's really driving this thing. And under that hood, you'll find NumPy. The name stands for Numerical Python, and it is an absolute beast. While Pandas gives us that nice, user-friendly data frame, NumPy is the high-performance engine doing all the heavy lifting, all the serious math behind the scenes. Now, here's the key difference, and it's a big one. A Pandas data frame is flexible, right? You can have a column of text right next to a column of numbers. But a NumPy array, that ND array you see there, is a specialist. Every single thing in it has to be the same data type, like all numbers. And that strictness, that specialization, is what makes it so ridiculously fast for doing math. So if Pandas is the comfy interior and shiny body of the car, NumPy is the high-performance, finely tuned engine. All right, we're almost there. Our little journey is nearing the destination. We started with a question. We used Python as our main tool. We got the data organized with Pandas, and we know NumPy is handling the math under the hood. Now, it's time for the payoff. It's time to turn all this hard work into a picture that actually gives us the answer. So let's go all the way back to the beginning. The question was, what's the real relationship between a car's weight and its gas mileage? We've done all the prep work. The data's clean and ready to go.
So, how does our toolkit take all these numbers and just show us the answer in a way we can see instantly? This is where the final piece of our toolkit comes into play, Matplotlib. Matplotlib is basically Python's go-to library for making charts and graphs. All we have to do is hand it our nice, structured data, give it one simple command, and it just transforms it into a visual, like the scatter plot we're creating right here.
And honestly, this is the magic of the whole thing. It really is just one line of code. That single command tells our toolkit to crunch through thousands of data points and turn them from this abstract table of numbers into a genuinely powerful visual insight.
And there it is. That's the picture that one line of code gave us. And the answer is just obvious, isn't it? You can see it right away. As the car's weight along the bottom increases, the miles per gallon on the side clearly goes down. What started as just a hunch, a feeling, is now a real data-backed conclusion that anyone can understand in a single glance.
So let's just quickly recap that whole journey, because this is the core workflow. We started with a question. We used Python as our language. We organized the data with Pandas into a data frame. We relied on NumPy as the engine for all the math. And finally, we used Matplotlib to visualize the answer. See? Each tool has its own specific job, and when you put them together, you get this beautiful, seamless path all the way from simple curiosity to real insight.
And this, to me, is the most exciting part. Look, we just used this process to uncover a simple story about cars. But this toolkit, it doesn't care about cars. It works for anything you can measure. Finance, biology, sports, you name it. The real power here is that this gives you the ability to ask your own questions and to go out and find the incredible stories that are hiding in all the data that's all around us.